So let's look at this next problem that we had in yesterday's notes, where there again is an x and a y. And I need to now, again, separate and then integrate. So my goal is to separate, then integrate. And I love how it rhymes. Separate, integrate. Okay? So in this sense, if you want, think about cross multiplying, and you get y dy equals x dx. Now all the y's are on the left, all the x's are on the right. So I'm going to integrate now. I get 1/2 y squared equals 1/2 x squared plus c. Okay? I always say plus c on the right. You could, if you wanted to, could you say a plus c over on the left side as well? Now here comes what I call fuzzy math. If you want to have that plus c there, that's totally fine. Fuzzy c. Well, now your goal is, let's rearrange this a little bit. So if you want, could I subtract the c from both sides? So I get 1/2 y squared equals 1/2 x squared, and know what I'm still going to call it? Plus c. And you might go, whoa, 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 whoa. C minus c. C minus c is 0, Bach. C minus c is 0. I agree with that if they were the same number. But I'm calling c any number, and I'm subtracting any number from it. Any number minus any number is still any number. That's why some of you might be going, woo, 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 woo. That's fuzzy math. I agree, it is. First time ever, you can go tell your folks at home, c minus c is c. They're going to be like, what? Go, trust me on it. Bach told me via video, because Bach had a baby. Bach's not here, but the video doesn't lie. Okay, let's do some more fuzzy math. Let's multiply by 2. And I get y squared equals x squared plus c. Whoa, 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 whoa. Isn't c times 2 2c? Yeah, you could say that. But 2c is a number, and I just want to know that I have a number out there. So, woo, 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 fuzzy math again. So again, now you can go home tonight and tell your folks, c times 2 is c. And they'll go, no, it's not, it's 2c. I'll go, no, it's c, because it's still a number. Okay? Now, when you look at this, I'm going to rearrange this a little bit differently. I know some of you might say, let's square root it and get y by himself, but I'm going to rewrite this as this. Y squared minus x squared equals c. I'm going to write it that way for you. And I might rearrange it and go y squared over c minus x squared over c equals 1. And you might go, I don't know why you wrote it that way instead of a different way. Well, way back in Algebra 2, there is a specific equation for a hyperbola. And that is where you have y squared minus x squared, or if you had an x squared minus y squared. And typically they had it over c's, or like it was an a squared and a b squared. Anyways, those make hyperbolas. And if you stare at this route over here, the black together is a hyperbola. The red together is a hyperbola. If you wanted to make circles, the only thing different would be you would do y squared plus x squared. If you add it instead of subtracting it, what would happen is this, the black, instead of bending out, it would bend in, and you would have a circle. Or likewise with the reds, it would bend in, and you would have a circle to it. Okay? So I separated, I integrated, I solved out, and I found that the paths created by the railroad track were hyperbolas. Okay? And how do I figure out if I needed to go through a specific town? Let's say right up there. How do I know how to solve for that? And let's say that town was 0, 1. Well, if you have that town, you can plug that town into the equation, and you could say 1 squared over c minus 0 squared over c equals 1. I could say that's 1 squared over c equals 1. I could say that's 1 over c equals 1. I could say c equals 1. So now I know if I have y squared minus x squared equals 1, that would create the hyperbola that gives me that route. Now it would also give me this route as well, but it at least gives me the track or the path through that dot. So that is how you can solve for a C value once you manipulate it through lots of fuzzy math. Okay? We got more problems, so hopefully bear with me. Okay, so I gave you 2 examples up front, and now I'm going to give you kind of the steps of separation of variables. Okay, the whole goal, again, to find the whole goal of separation of variables is to find the path through the slope field, which means find the railroad track. Okay, so your goal, typically you want y's on the left, and x's on the right. Make sure the dy and the dx are on top for both sides. Integrate both, but only have the plus c on the x side. Okay, so those are the first 3 steps. The big thing to realize, what I meant on that middle one, is you need to have the dx, you need to have the dy up on top. You've never had a dx below. You've never had a dy below. Anytime you've integrated, you might have had fractions, but the dx or the dy always remained on top when you really integrated. So that red is wrong, but the green is right. Okay, the dy's and dx's on top. Okay. Fuzzy math of the c. So remember, c plus c, that's c. 2c equals c. c minus c, c. E to the c is still c. All true until you officially plug in the point. You can plug in that point anytime after you integrate. So I'm going to talk about this on the next couple slides, but I don't care that 2c is c. I don't care that c minus c is c. I don't care what fuzzy math you do. But once you plug in a point and once you solve for that actual c, it then becomes a number. It's not a random number, it becomes a specific number. And we'll look at that throughout. Okay, fuzzy math, it's fun, but some of you will say it's frustrating. All right, so we have a problem like this. I think this one is actually on your worksheet as well, and we're going to solve it. Okay, this is an ultimate problem. This blends yesterday and today together. It blends yesterday because it has a slope field that we're going to do some tick marking on. It blends yesterday because you have a town at 0, 2. I'm going to draw the path of that town, and then my goal is to get that actual path. Notice again, there's x's and y's. That's the new stuff today. We have x's, we have y's, so we have to do both with that separate integrate. All right, so if I do the tick marks here, anytime x is 0, 0 divided by anything is 0. Now you might go, why didn't I plug in at 0, 0? Well, that would be 0 divided by 0. Uh-oh, I don't know, that's scary. Yikes. Okay, next thing. Anytime y is 0, I'm getting a number divided by 0. And we mentioned that yesterday. A number, let's say 1, divided by 0 is up 1 over nothing. So those are vertical slopes. And again, I did not do anything at 0, 0 because I don't know what 0 divided by 0 is. Now you just get to plug in points like 1, 1. And that's a negative 1. Negative 1, 1 is a positive 1. Negative 1, negative 1 makes this and this. And you can, I know this one so well, that's why I'm doing it somewhat quicker than it would take you guys. Okay? But hopefully you notice it seems to be circling around. And you really would take a lot longer to do this than I would, okay? I just know it circles around. Could you physically find those slopes and be a little bit more exact? Yep. Okay. Now, I'm going to plot the town at 0, 2. There's my town. And I want to know what the track looks like. What's the path look like through this kind of slope field? So it looks like to me it goes and follows that. My prediction is a circle. And more specifically with radius 2. So that should be x squared plus y squared equals 2 squared, which is 4. That's what I bet the path is. I want to prove it to you that that is the path. And the way to prove it to you is to separate and integrate. Okay? So we're going to separate. We're going to integrate. Okay. All right, so I got, let's see, dy over dx equals negative x over y. I got y dy equals negative x dx. I basically cross multiplied right here. Okay. All my y's are on the left. All my x's are on the right. So I should be ready to go with the integration. I'm going to integrate. I'm going to get 1/2 y squared equals negative 1/2 x squared plus c. Okay. Now, I want to do this one of two different ways. Right now, I have totally integrated. So if you want, you could plug in right now and solve for c. So let's right now plug in now for c. Let's see what happens. So I need to plug in the point 0, 2. So I got 1/2 2 squared equals negative 1/2 0 squared plus c. I get 2 equals c. Now that I know 2 equals c, I could rewrite the path as 1/2 y squared equals negative 1/2 x squared plus 2. Let's rearrange this a little bit. Let's multiply by 2. I get y squared equals negative x squared. Now, since it's a physical 2 on that right side, it is no longer c. It is 2. What's 2 times 2? Now you have to do what you're so used to with saying 2 times 2 is 4. Because it's not a c anymore, so I'm not doing fuzzy math on c. I'm doing 2 times 2 is 4. So then I can add the x squared over. And I got exactly what I predicted. Woohoo! Okay. Now, I left some space over here on the right because I don't want to plug in for c yet. Let's do fuzzy math first. So, what I would do next, if I was doing the different route, way 2, is I would multiply by 2. I would get y squared equals negative x squared plus c, because 2 times c is c. It's not 2c, it's c because it's just a number. Okay. Maybe I would add the x squared over and I'd get x squared plus y squared equals c. Now let's plug in. So now plug in. I would get 0 squared plus 2 squared equals c. And so I get c is 4. Now you might go, wait a second, c is 4 on one of them, but c is 2 on the other one. Did we do something wrong? No, we didn't, because look what the equation becomes then. If I know c is 4, I plug that into there, and x squared plus y squared equals 4. So the whole thing is, I don't care what c is at all. I care what the equation is in the end. So if you plugged in earlier, you might have gotten c is 2. Or maybe you plugged in later, you got c is 4. I don't care, because in the end, when you write your equation, you're going to have the exact same equation. So when I'm grading a test, I do not care what the c value is. I care what your end result is. What is your path? And we made the prediction, and it was 4. In the end, x squared plus y squared equals 4. That's what we care about. Okay? Let's look at one more. Okay? Again, this involves a y to it. So we are going to try and solve this. You can set up all of the tick marks. I'm going to do them pretty quick for you here. 3y plus 6. I'm going to plug in first so you can see it. Let's plug in when y is -2. When y is -2, you get that to be 0. So flat, 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 flat. If you want, you could then plug in y is -1. And you get -3 plus 6 is 3. So pretty steep, pretty steep, pretty steep, pretty steep, pretty steep, pretty steep, pretty steep. You could change it and have y is 0. And you get 6. Really steep, really steep, really steep, really steep, super steep, super steep. They basically go really steep from here on out. Now you might go, wait a second, what happens at -3? So at -3, you could go 3 times -3 plus 6, and you get -3. So now this slope bends down. Okay. Again, remember, since everything is only in terms of y, that means horizontally, all the tick marks are the exact same. Okay. So now it gives me a point, gives me a 0, 1. And I want to know what my path looks like. And it feels like it would be like this. Like, let's call it almost like an airplane takeoff. Okay, my goal, I want to know the exact equation of that red path through that slope field that goes through 0, 1. Okay, so to do it, all right, dy dx equals 3y plus 6. Now, the goal is to separate and integrate. You do not want to do something like this. You're going to erase this in a second. Let's move that dx over. And let's subtract the 3y. There we go. I have it. No, 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 no. First off, that's illegal, because if you did move the dx over, you would have it as 3y plus 6 dx, so you could not subtract the minus 3y. When you separate and integrate, you're basically always multiplying and dividing. You do not want to split up the 3y plus 6 by subtracting them out. They are chunks. So instead, I'm going to do this for you guys. I'm going to first do this. dy over dx equals 3y plus 2. Now I am going to move the dx over. I'll do this in baby steps for you. And I'm going to move the y plus 2 over. You could, if you wanted to, move the 3 over. I would not. I just like keeping any of those numbers over on the right. So I got dy over y plus 2 equals 3 dx. It's separated. My dy is on top. My dx is on top. That is good. So we should be able to solve now. Here comes the integral. No exponent on the bottom of the left. That goes to ln of y plus 2 equals 3x plus c. Okay. From here, I'm going to solve for y. So I'm going to e both sides. Remember, the e to the ln should keep the absolute value in there, but just trust me for right now that you can get rid of the absolute value and say that just goes to y plus 2. And this is e to the 3x plus c. Here comes some fuzzy math stuff. Y plus 2 equals e to the 3x times e to the c. Y plus 2 equals c e to the 3x. Why can I do that? All I know is I have a number. It's a number. Somehow it's a number, so I'm going to keep it as a number. So I have it like that. I could say y equals c e to the 3x minus 2. Now, I always like to go as far as I can, and then now I'm going to plug in, what was it, 0, 1, I think? 0, 1. So I get 1 equals c e to the 3 times 0 minus 2. 1 equals c minus 2. C equals 3. So my path is y equals 3e to the 3x minus 2. And if you want to graph that, I promise you it will look like that airplane taking off.